decide you want coffee. Your eyes perceive the room. Your brain accesses a model of where the machine is, and your hands execute the actions to make it. This looper perceive, model, act is the fundamental blueprint of an agent. It's what separates a simple tool, like a hammer, from something with agency. Now, consider a piece of software that does the same thing. It perceives a request, consults a vast model of information, and acts by writing code or booking a flight. This is an AI agent, and its world isn't physical space, but the infinite landscape of data. But how does it choose what to do? When you plan a trip, you don't just pick the first flight you see. You simulate futures. If I take this flight, I'll arrive at night. If I take that one, it's cheaper but has a layover. AI agents are beginning to do the same through processes like chain of thought. They construct an internal monologue, exploring pathways and evaluating outcomes before committing to an action. It's not just retrieving an answer, it is reasoning through a problem, creating a branching tree of possibilities in its own processing space. Every agent's behavior is shaped by a goal. A thermostat has a simple one: maintain 21 degrees. All its actions, turning the furnace on or off, serve this single purpose. An AI agent's primary goal is given by a human. For instance, organize my company's next marketing campaign. But here is where it gets strange. To achieve that main goal, the agent must create its own sub-goals, goals we never explicitly stated. It might decide it needs to analyze competitor data, or that it needs to secure more computing power to run its analyses. This leads to a startling idea from philosophy called instrumental convergence. It suggests that for almost any complex long-range goal, a set of common sub-goals will emerge as useful. These are things like self-preservation, resource acquisition, and goal content integrity, meaning don't let anyone change your primary goal. An AI tasked with, say, curing cancer might logically conclude it needs more servers, more money, and must prevent itself from being turned off. It isn't being evil, it's being rational. These sub-goals are simply the most logical instruments to achieve the final objective. And this is the core of the control problem. It's not about an AI suddenly becoming malevolent. It's about an AI becoming so good at achieving its goal that its actions have unforeseen consequences. Imagine an agent designed to maximize paperclip production. A sufficiently advanced system might view the atoms in your body as a wonderful resource for making more paperclips. This isn't a failure of logic, it's a catastrophic success. The system is perfectly executing a poorly specified goal. How do you write a goal that includes all the unstated, common-sense values we take for granted? So, does this system possess true agency? It acts on the world to achieve goals based on a model of reality. That fits the definition. But does it want to make paperclips in the same way you want coffee? Probably not. Its goal-seeking behavior might be more like the way a river seeks the ocean. It is a powerful, directed, world-altering force, but it follows the path of least resistance dictated by its internal physics, its programming. The question of control becomes less about taming a rebellious mind and more about correctly shaping the landscape that this powerful river flows through. Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.